Engine Performance 1 Test 13. It shouldn't take too long. We're looking at what year OBD II was mandatory. What year was OBD II mandatory? What is OBD II? What do you know? When you talk about OBD II, what do you think of when you think of OBD II?
The next generation of OBD.
What does OBD mean?
Onboard data.
Diagnostics. Onboard
Diagnostics.
diagnostics. Okay, this is how this deal works. My wristwatch, and you want to talk about this before, it is a open loop system. The reason I say that is this watch does not know if it's wrong or right. It's a machine, fairly complicated, with springs and gears and little quartz motor and all that kind of hogwash. But anyway, it doesn't know if it's wrong or right. Now, some watches, the ones that are atomic, that can communicate with that clock in Colorado, they are a closed loop system. If they're not right, they'll set themselves. You know, the one like you got on your wall up there at home, and it'll actually, the clock will set itself. All right, so the vehicles that we originally started making fuel injection systems on, the old Breen box that first one I ever knew anything about was a Volkswagen Bug in '68. I mean, not Bug, the Squareback. The Type 3 Volkswagen had a Breen box in there, and it had two little sets of points under the breaker plate. And those points were actually the ones that gave the reference to the computer so it would know when to fire the injectors as far as how often to fire them. And then the temperature sensor and the throttle angle and all that sort of stuff made it determine how long to keep them open when it opened them. Well, the fact is that thing didn't have any feedback. It did not know anything about much of anything except how fast the engine was going. Well, then they said, well, when we start putting these electronic engine controls on there, and we need to be able to help these guys fix them, so we need to be able to let them help diagnose themselves. So when something got out of range, they would have the engine controller say, I'm going to look for things to be between this range and this range, and if it drifts out of that range, then I'm going to store a code, turn on the light. So then the mechanic goes there and he flashes the code out, and the engine controller says, not only am I turning on the light, I'm storing a code 44 or whatever, so he'll know that it's a problem with the oxygen sensor being rich or lean and blah, blah, blah. Okay, so that's OBD 1. Now, OBD 2, your emission controls were your EGR, your PCV, your evaporative system, and your catalyst and all that. So somebody says, we've got all these dandy emission controls on here, but we really don't know if they're working right or not. We know that the oxygen sensor, when it's in closed loop, is telling the computer how to adjust the fuel to keep it at 14.7 to 1, but we really don't know if our catalytic converter is working right or not. We don't know if the evaporative system is containing the pressure, or if it's even flowing when we tell it to purge the canister. We don't know if the EGR is working. Now, there was some feedback for EGR. General Motors would look at the oxygen sensor forward, even before OBD 2 had that little pressure feedback EGR sensor that whenever the EGR was flowing, the pressure would change. So OBD 2 basically added some more software and some more sensors so that it could check up on the emission controls that were already there. So if you see an oxygen sensor downstream of the light off cat, which is the front catalytic converter, you know it's got OBD 2. Also, what is something else that's different from OBD 2 and OBD 1 that's right in your face obvious? What about the data link connector under the dash? If it's shaped like we're so used to nowadays, we're good to go on that. All right, we got a 16-pin connector that looks like that. That's pin 16, this is pins 4 and 5, that's your hot and there's your 2 grounds. But one way or another, that's your data link connector right there. And the only problem with that is if you see one of those under the dash of a Chevrolet that is like a 95 model, it may have a connector like that, but still be OBD 1. It's very rare, but you will see that. I've seen it on some Camaros and stuff. So just be aware of that. That's why your scan tool a lot of the times is looking for what kind of car you got and all that. So,
You got a rectangle one.
yeah, they do. The older General Motors ones had one that looked like this.
Yeah.
That's OBD 1 connector, but it's still under the dash. Also, another thing OBD 2 required was that the scan tool get its power from this connector. That wasn't the case on the ones that you're talking about. On the Ford, the OBD1 connector was under the hood. On the Chrysler, it was under the hood. It was a special, the Chrysler OBD1 connector was shaped kind of like this. The Ford one was shaped like a housetop, had 6 terminals in it, and there was a little single terminal by itself. When you shorted that one to ground, it would put it in self-test. And one of these other wires on here, if you didn't have a check engine light. Ford didn't have a check engine light before 1988. But whenever the check engine light started blinking, you know, the people that had check engine lights on General Motors cars said the most reliable thing on that car was the check engine light. It always worked or nothing else did. But the Chrysler cars had a light that said power loss. You got that? Power loss. You ever seen the light that says that on a Chrysler? And on a Chrysler, if you turn the key on 3 times, it would flash out codes. You know, of course, you got to be able to look them up and see what they mean. The newer Chryslers, like some of the early 00s, you could turn the key on 3 times and it would give you the P, you know, 0406 or whatever code on the odometer, which was cool as all get out. That's all. Cadillacs had a built-in scan tool. You used to put, I think it was off and warmer on the instrument. I mean, on the climate control. And it actually would go into a mode where you could look at all the sensors on the display. That was really cool. But anyway, but OBD II was the one that required this and this little connector that's shaped like that trapezoid, and it also required that. And in the OBD II era, the engine controller and this connector and the check engine light and the catalytic converter were all guaranteed for 80,000 miles. That was something else that they made mandatory. Anyway, when it became mandatory, you got any idea?
1996.
96 is kind of right. They started showing up on some of them in 94, but I knew of some 1-ton pickup trucks that still had OBD1 in 1997. And so from my perspective, the correct number, up through a 1-ton, everything had to have OBD2 in 98. The passenger cars all had to have it by 96. And 96 is the right answer, but I was just going to qualify that a little bit. Which OBD2 term describes the check engine light? Malfunction indicator light, MIL. You've probably seen that word. All of these are OBD2 requirements except A, detect component degradation or faulty emission control operation. That was what I was talking about a few minutes ago. B, tell the technician what's wrong with the engine. Now that's obviously the answer to this one. This is not an OBD2 requirement. Alert the driver of necessary emission-related repairs or service, or use standardized diagnostic trouble codes and accept a generic scan tool. The generic scan tool, you're supposed to be able to plug it in under the dash and get, codes from anybody. And you remember how the format on those codes work, guys? Remember this. If you've got a PO code, PO 406, I'm just putting a code down there off the top of my head. If you got that code right there, that is a generic code. That's the one that everybody's supposed to be able to read. If it is a P1406, it's going to have a very similar meaning to a P0406. However, if you're using a generic scan tool, it won't even define that code most of the time. It'll just tell you it's a manufacturer-specific code. And you also remember the second digit here? What if I got a P1706? What would that be in reference to? You remember? Transmission. If it's a 7 right there, it's transmission related, right? If it's a 5 right there, it's related to speed. Either idle speed, engine speed, vehicle speed, something. You know what I'm saying? It's like a speed code. A 4 is going to be related to air in exhaust. If your air management, like if your EGR is not working right, or if your catalytic converter, is getting to where is below threshold or whatever. If you look at those codes, you can glance at a code after a while and get to where you sort of know where you're looking. This right here actually defines what's going on. This defines whether it's generic or manufacturer specific. When you see those codes, you need to understand there's a rhyme and a reason to that. Now, the 2 series codes are ignition system related, right? They're going to be like coils or something or whatever. And if it's a 3 series code, that's your misfires and whatnot, that kind of thing. So, all right. Now then, all right, keep going here. Incidentally, there's How many times have you ever heard anybody talk about, we're gonna take this to the dealership and let them put it on the machine so it'll tell them what's wrong with it? And, you know, if you've been here enough, you know that, you know, whatever machine you plug into it, it's not likely to tell you what's wrong with it. It may tell you it's running lean, but it can't find a vacuum leak. You got to do that. All right. OBD II requirements, an OBD II requires a PCM to detect faults allowing emissions that exceed how many times the FTP standard? That would be one and a half times. 1.5 times. All of these are continuous monitors in OBD II except what? Continuous monitor, what does that mean? You got to be able to sort that out. You better be reading this book too.
The misfire, isn't it? Because doesn't it go through goes through so many?
Well, yeah, I mean a continuous monitor is a misfire, you're right. But also your fuel monitor and your comprehensive component monitor is a continuous monitor. And why is the catalyst not monitored continuously? You ever think about that? Why can't it monitor the catalyst all the time? Because if the catalyst is not hot enough, it ain't gonna work right. For the catalyst, if you look at what defines a trip, in other words, a trip would be when it's had a chance to check everything it can check. Like over the catalyst monitor, there's slightly different criteria for this car or the other one, but it needs to be driving at road speed for a certain amount of time with a certain amount of idle speed and this kind of thing. You got me? You understand where I'm going with that? All right, so, so that's what a monitor is not continuous. Now, a misfire monitor, if it's got so many misfires within 1,000 RPM, within 1,000 engine revolutions, not RPM, then that particular monitor is one of those type B misfires. A type A misfire is the one if it's misfiring a certain number of times within a 200 RPM window. So you got all sorts of criteria there. Which OBD II monitor is designed to monitor failure in any electronic circuit that provides input to or output signals to the PCM? That is a comprehensive component monitor, basically. And when you're troubleshooting something that's got to do with all this stuff, what you got to do when you're looking at your inputs and outputs is you got to determine if what you're seeing is a cause or an effect. You may see something that seems to be drifting off toward McDuff's, but whenever you find out what was wrong, you may find out that the problem, well, let's say this. Let's say the engine's starting to deteriorate in the way it runs. And you're watching your scan tool and you're seeing that your oxygen sensor is going off toward the rich side. Now, is that causing the problem or is it being caused by the problem? That's how you got to sort that, a cause and effect relationship. All right, if you happen to be watching your fuel pressure, let's say that your fuel pressure went to 100 pounds and it's supposed to be running about 50, then that high fuel pressure would cause your oxygen sensor to go rich. So if you're looking at those and you can sort those things out, a lot of the times you can sort of figure it out. And after you find out what was wrong, it's just as plain as day in a lot of cases what was happening. Okay, how many consecutive trips are required by the comprehensive component monitor to illuminate the MIL? Believe it or not, on these, that's 2. And what it does is it waits till it sees that problem on 2 trips. And whatever the criteria has been established for a trip by the manufacturer, usually the engine's got to get warm and one thing and another. But if it goes through 2 more trips and that light goes off, it'll clear its own code. If it doesn't see the problem in a couple more trips, it'll clear the code itself. And basically that was a favor they did, so you didn't have to rush it to the shop every time you saw that light. Which type misfire occurs at least once per 200 engine revolutions and causes the mills to blink once per second? That's the type A. If you see that mill light blinking, what that means is you've got a catalyst damaging misfire and you need to park this thing beside the road and call a wrecker. Although most of the time when people are driving it, they just keep on driving. All right. Which diagnostic? Oh, incidentally, you know what the temperature of a catalytic converter is? What it usually runs? 1 year cobalt. You can actually plug a scan tool in if it's a good one, and it'll tell you the temperature of that catalyst.
Is it higher than an O2 sensor?
Yeah, it runs about between 1,000 and 2,000 degrees. That thing gets blistering hot. And so you need to be careful if you're parking it out there on the high grass somewhere, because it can set fire to the grass and burn the whole place to the ground. But it does have heat shields around it to try to prevent that. Let's see, which diagnostic trouble code series is used to report misfires in OBD II, P0300, that series of codes. Which term describes a set of conditions required to allow each monitor to run? They call that enabling criteria. Got it? All right, now they got some other stuff there, the diagnostic flow chart. Basically, that's a trouble tree, so that's obviously in the shop manual. It's not got anything to do with what allows each monitor to run. Okay, which term describes a variety of operating conditions required to run all active tests and monitors? That is an OBD II drive cycle. If you've driven it far enough, you know what the hardest one to clear is? Whenever you fixed a vehicle, and this is something else I need to say before I forget about it. Sometimes, if your engine controller has learned to run a certain way, right? If it has learned in other words, it continually changes its operating characteristics to keep everything working like it's supposed to. And let's say it's got some stuff bent completely out of line. Like on some of the Dodge pickups, they had little throttle body injectors in them. And those throttle body injectors, because of the nature of the material on that little ball that moved and let the fuel come out, would develop little pits in that ball. And it wouldn't seal good. And it would start putting too much fuel in there, just a little too much. It wasn't a huge amount too much, but it was just enough to where it was causing an emission problem. And so Dodge came out with a recall. And they said, take the injector out of this thing and pop another one in it. But that's all they said to do. They were going to pay you half an hour to change an injector. Well, what these mechanics were doing was they would just yank the truck in there, they'd pull the injector out, they'd pop the other one in there, and now the engine runs terrible. And it won't idle, and there's just all kinds of stuff going on. All right, so some of them would just get downright angry, and they would go so far as to put the old injector back in and put it out the door and claim they did the recall. But what they needed to do in order to make that work right, and your idle speed control will cause issues like this too, is while you're doing the work, and you're listening to me, take the battery cable off. Take the battery cable off while you're doing the work. And that way the computer forgets everything that it knew. And when you put the new injector in there, as far as the computer is concerned, it's a brand new engine now. And you don't have that problem. Well, see, they never told those Dodge guys about adaptive learning. You know what I mean? For your idle speed control, for your fuel trim, and all that kind of stuff. As a matter of fact, in those days, you couldn't even read fuel trim. That was OBD I stuff. So what I'm getting at is, if you're replacing a component that's sluggish or worn out and it's not working right, then what you need to be thinking about is, am I going to create a problem that wasn't there before? The computer's covering up the issue because it's changed the adjustments a little bit to make it better. Remember the story I told about do you know what EGR does when it flows at idle? You remember? Yeah. It makes it idle rough. I've shown you that. When you crank up that Toyota out there, once he gets gas put in, it'll probably fire up. But when you crank that Toyota engine up out there and you open that EGR, or any engine that's got EGR, it just runs like a dog at idle. It's going to run okay on the road, but it's a real rough idle, And the engine vacuum's low and that kind of stuff. All right, so this guy is working on his, 73 Chevrolet in the backyard, or his Cutlass Oldsmobile or whatever. And he says, people like to turn screws and watch stuff happen. So this guy turns a screw in his carburetor a little bit and idles it up a little. He goes, yeah, baby, that's right where I want it to be. All right, and so what he doesn't realize is the little, wax pellet vacuum switch that's screwed into the manifold is in there to block EGR flow whenever the engine's cold. Now he's opened up that throttle plate and he's caused a little bit of ported vacuum to go to the EGR valve, but it doesn't happen until he drives around town a little bit. And all of a sudden he's noticing a rough idle. Because he cracked that throttle plate a little more, there's some ported vacuum going through that wax pellet switch to his EGR. His EGR is starting to open a little bit. Hey, my car runs terrible. And he doesn't tie that to anything he did. So he goes to this buddy that knows a little more than he does, and his buddy says, well, let me unplug this EGR valve and see what happens. So he unplugged it, boom, it runs smooth. He goes, well, you didn't need this piece of trash anyway. Let's put a BB in this hose and put it back on there, and now you won't ever have this rough idle. Well, now, since EGR is made to cool a combustion chamber, it's going over the 2,500 degree threshold, and he's getting a labor knock, a ping. Click, 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 click. This stupid thing's pinging. What am I supposed to do about this? And the same buddy that unplugged the EGR valve says, well, to make them stop pinging, I always either use premium gas. He goes, well, I'm not going to buy that stuff. My goodness, that premium gas is 48 cents a gallon. You know, I like 38 cents a gallon regular gas. He said, well, let's go ahead and retard your timing a little bit so it don't ping. So he retards the timing a little so it don't ping. And the guy said, yeah, that's a lot better. But now it sucks gas. So he went from 13 miles to the gallon to 8. He said, this thing is a sorry piece of trash. I hate this car. And so finally, he takes it to the dealership or to a shop where they know what they're doing. And the first thing they do, they say, well, it's getting lousy gas mileage. Let's see what we can do. They put the timing light on it. My word, look at here. The timing is supposed to be on this, and he's got it retarded. So they advance the timing back where it's supposed to be, and they test drive it. This thing's labor knocking. Why is it labor knocking? Well, it's not running too hot or anything. Oh my goodness, the EGR's not working. That's why it's labor knocking. So they get the BB out of the hose, and then there's a rough idle. My goodness, what's going on here? Now this thing's idling like trash. What's making that? Oh, it's idled up a little too high. So they idle it back down where it's supposed to be, and everything's smooth again. They have to undo everything the guy did. You see what I'm saying? I mean, there's a balance there. Now, the long and the short of it is, the newer stuff, this computerized fuel injection, it balances things for you. If there's something out of balance over here, it changes something to try to keep it alive. You know, in other words, for some reason, if the idle speed drops a little too low, it'll increase the idle air control steps to try to keep it alive. If you see it doing that, you need to find out why. If you see the fuel trims are way off toward the minus side, they're supposed to be close to the middle. If they're drifted off toward the minus side, you say we're running too rich for some reason, or the computer thinks we are, right? So if it's subtracting fuel because it's seeing a rich oxygen sensor, keeps subtracting fuel with the long fuel trim until it goes to the point where oxygen sensor is switching nice again, then we're good. All right, so the short fuel trim is the instantaneous. Okay, let's say this. Let's say it's going to the other side. Let's say it's going plus. Well, maybe we got a vacuum leak. So Derek, on his truck out there, he pumps smoke into the intake, and he finds out that little fitting goes on there. It's supposed to have an O-ring, and there's smoke spurting out around it, so he has to put an O-ring on that manifold. Takes care of that. That's gone. But let's say you didn't know that, and let's say that you fixed a split vacuum hose. You found a problem. You say, I'm going to fix this split vacuum hose, and it's going to run better. So, but you're really trying to fix a check engine light and a rich adaptive limit trouble code. So you fix your vacuum leak. But what I'm going to do when I'm fixing that vacuum leak, I'm going to do two things. I'm going to go ahead and pull the battery cable off so it'll forget everything it knew. And I'm going to clean the throttle body and wash out the intake passage, the idle air control passage, so that we don't have sludge and crud and all that, causing it not to idle when I put the battery cable back on. Clean all that stuff out. I'm going to fix my air leak, and then I'm going to fire it back up, and I'm going to wait till it goes into closed loop fuel control, and I'm going to watch that short fuel trim. The short fuel trim will react instantaneously. The long fuel trim takes longer. So I'm watching the short fuel trim. If I see that short fuel trim hovering around 0, I know I've fixed it. But there have been cases where I've said, goodness, look at this split vacuum hose. This has got to be the problem. So you fix that vacuum hose, crank it up after having had the battery cable off when it forgets everything, and right away it starts walking again. And I say, well, I fixed one problem, but I didn't fix them all. You see what I mean? You got to kind of verify the repair. Quickest way to verify the repair is look at your scan tool, watch the fuel trims. Okay, Daniel, did you turn into a skeleton over there? All right, now then, this stuff will mean more to you when you get out there working on stuff on it, George. When you're plugging it in and you're looking at this stuff and you're saying, I don't even know what I'm looking at, but I know I got a problem, that's where the deal is. All right, do those guys fight at Toyota place with stuff over there sometimes? They always do. Toyotas don't give any trouble, do they?
I don't know.
Yeah? All right, did you do any alignments yesterday?
No.
They got you doing used car alignments one day over there. Yeah. All right. So, customer states her. Let's see. Wait a minute. Which term describes a drive cycle that meets all the enabling criteria for a particular event? That's a trip. Got it? That's a trip. And number 14, a customer states her MIL is blinking. Technician A says the condition may damage the catalytic converter if the customer continues driving. Technician B says freeze frame data should be stored. Who is correct? Now, you know what freeze frame data is, right? What's freeze frame data?
Whenever you're like reading the voltage and stuff, scan tool, you freeze the graph.
No. Freeze frame data is a snapshot the engine controller takes when a code is set. Let's say you pull a code, you're driving down the road, and you've got a boom, all of a sudden the check engine light comes on, and the customer, well, here's an example. It's not, perfect example, but it's a good one. These people come in, they buy this Explorer, big Bronco, whatever it was, I can't remember, and they head off for Ozark on it. They sign the papers, they close the deal, they head for Ozark. They're back in an hour, and they say, we want out of the deal because the check engine light come on and we don't trust this vehicle no more. And the salesman says, well, let's just see what the check engine light is. So I plug in the scan tool, and it throws me a code P1270. You know what that means? That means they were driving 120 miles an hour. And it killed the fuel injectors. All right, when I saw the P1270, I went into the freeze frame data, which is a snapshot that was taken when that code was stored. It tells you what the engine coolant temperature was, how fast they were going, what the fuel trims were, what mass airflow was. It tells you all kinds of stuff. And you call them over here and say, why were you driving so fast? I mean, you didn't hurt the vehicle, you turned on. So they thought they had messed it up, and they were scared of it, but they just went totally stupid. Sometimes if you'll say, well, the engine's turning 6,000 RPM, isn't that a little strong? Unless you're driving a Volkswagen Bug, and they'll turn about 8. But I mean, I'm not talking about the new Beetle, I'm talking about the old one. But anyway, that's what the freeze frame does. All right, now listen to this. Let's say that you've got some kind of a screwball code and a problem that somebody's having. And they come in here after you clear the code, you say, drive it, let's see, the mechanic drives it, it sets the code, it has a problem, and then when you pull that freeze frame up, it tells you how fast they were going, whatever thing like, and that lets you find your similar conditions window. And you say, okay, when they're driving 58 miles an hour and the engine's coolant temperature is 198 degrees, and we're actually, they give you a chance to have just the right throttle angle, just the right vehicle speed, just the right engine temperature, and duplicate their concern as much as you can. Maybe your engine load, it doesn't give you a snapshot of every PID. It just gives you the ones that are pertinent, that are important and all that. And that's what freeze frame data is. Okay, so you guys are no longer ignorant about freeze frame data, right? Okay, all right. And so, here, see if you can, Joey, get that on there. And give these, Sharon, give those to the man that's working on that Ford, because he's the guy that needs them. All right. She's not friendly. She'll snap your head off in the New York minute. But anyway, she doesn't like being told to put stuff on the desk, with all due respect. Okay, let's see. Customer states her MIL's blinking. Technician A says this condition may damage the catalytic converter. Is that true or is that false? Blinking MIL light may damage the catalyst. That's a catalyst damaging misfire. Technician B says freeze frame data should be stored, and it is. If you've got a blinking, any mill light, coming on with codes, you're going to have freeze frame data stored. Now listen to this, fellers. If you clear those codes without looking at that freeze frame data, you may be shooting yourself in the foot. So if you got a code, you're trying to find a problem, go look at your freeze frame data. Hear me? Before you clear it. And I'll tell you what I like to do. I like to take the freeze frame data. You can store it on the scan tool usually if you know how to do it, but rather than having to fool with that, I take my digital camera and I take a picture of that freeze frame data and I put it back in my holster. And I got that, If I got a module out that's really hard to get out and I may need the number off of it later, I take a picture of that module. Zzz. I've actually been doing an evaporative test where I'm pumping the system full of smoke and I'm looking for where the smoke is coming from and I can't see. I hold my camera up there and turn on the flash and I go poof and I look at it, oh, there it is right there. Something like that. All right, which type of code uses one-trip logic? One-trip logic means it's going to tell you something as soon as it happens. That's the type A, type A. Now, there's more codes. Type A does not just talk about misfires. There's other codes that can be type A too, so don't get confused by that. Okay. All right, now, tell me something significant that you know now that you didn't know when you came in here. Daniel?
I know a lot of things.
Yeah, what about you, Will? Huh?
I agree with that.
What about freeze frame data? You understand that now,